For our last section in 8.3, we are going to be tasked with calculating the length of some line segments. So we're doing this in a couple of different ways. Number one, I've given you a picture of a triangle here with a missing side length. And then number two, we've got these points right here where we're going to put them on a graph and then figure out the length of those line segments. Now we need a review on the Pythagorean theorem in order to be able to calculate the length of this. So I'm going to do that over here. Pythagorean theorem is used to calculate the lengths of line segments for right triangles. So here is a picture of a right triangle, and I've labeled the sides A, B, and C to go along with the notation for Pythagorean theorem that A squared plus B squared equals C squared, where A, B, and C are the lengths of all those sides. So if you know two of them, you can plug it into here and then solve for the third one, figure out what it is. So for our example right here, we've got A, we've got B, and we need to remember one thing is very important, that C is the longest side out of all these three. It's always going to be opposite that right angle right there, opposite the right angle right here, even if our triangle is turned around. So we're going to plug those values in to our Pythagorean theorem and solve. That gives us 3 squared plus 4 squared equals C squared. 3 squared is 9. 4 squared is 16, and we're going to leave this as C squared. 9 plus 16 is 25, so we get 25 equals C squared. To eliminate that square, we're going to take the square root of both sides, and we get C equals 5. So the length of this line segment right here we now know is 5. For these, we're going to put them on the graph, and we're going to see if we can figure out the lengths of some of those sides. Now, I only have one single line right here, but when we've been doing slope, over and over we've created triangles by going over and down or up, left, those different directions, and we can figure out the lengths of the sides of these horizontal and vertical edges very easily just by counting. So this side is 1, 2, 3 units in length. This side is 1, 2, 3, 4, 5, 6 units in length. And we don't know what that one is. This is the longest side opposite our right angle, which is right there. So this is C. Let's plug it in. We get 3 squared for that side plus 6 squared equals C squared. We don't know the length of that one. 3 squared is 9. 6 squared is 36. And when we add together 9 and 36, we get 45. Now from here, there's two things we can do. We're going to take the square root, and the square root of 45 is not a nice number. So we can either leave it as the square root of 45 if it asks us to do an exact value. So pay attention. If the question says, what is the exact value, you have to leave it here with the square root symbol. Sometimes, however, it'll ask us to approximate it, in which case we're just going to plug it into our calculator. So we do square root of 45. That gives us 6.7082, and that decimal keeps going forever and ever. We can round to the appropriate place and put it in decimal form if we wish. So remember, that's the exact answer. This is our decimal form, which can be rounded. Either one of those gets us the length of the line segment. This one, let's do that now. We're going to go straight down, straight over. Calculate the lengths of those. Just count them up. 1, 2, 3, 4, 5, 6. And over 1, 2. So we're going to do A squared, which is 6 squared, plus B squared, which is 2 squared, equals C squared. 6 squared is 36. 2 squared is 4. And when we add those together, we get 40. Taking the square root is, again, not a nice number. So if it's exact, we want to leave it as the square root of 40. If it asks for a rounded decimal form, we're going to plug that into the calculator to get 6.3245, and it keeps going, so round to the appropriate place, equals C. So we now have these two line segments. You will also be tasked with comparing them and seeing if they are congruent. Recall from earlier in the section that congruent means they're the same length. These are not the same lengths. We can see that in the exact form with the square root or with the decimal form, that they are not the same thing. And we can see that this one is longer. So the question asks what is longer, or which one is shorter. We could then indicate that and say that AB is the longer segment and CD would be the shorter segment. Thank you.